Assalamu alaikum. So, guys, our today's lecture is about paired sample testing of hypothesis. In this scenario, we usually collect the observation from same sample twice. For example, in case of medicine data, we have may have a sample of patients whose blood pressure is measured before treatment and after treatment to check the effect of the treatment, either treatment is effective or not. Or for business example, we may have data for certain organizations about their profit before advertising and after advertising to check whether the advertising has impact on the profit of organization or not. The case is the same sample, but the observations are taken twice. It is also known as matched sample or repeated sample. Our today's lecture based on an example of 10 mice whose weights are measured before treatment and after the treatment. So in this case, our hypothesis is the null hypothesis. Treatment have no effect on the weight of mice means the weight of mice is the same as before the treatment and after the treatment. And then the alternative hypothesis, the treatment have affected the weight of mice means the weight of mice has changed after the treatment. So the next step is usually specification of alpha. So here I am going to take the alpha 0.05, also known as the level of significance. And the next thing is deciding the test statistic. As we have discussed in class as well, that test statistic based on the normality. If data is normal, we usually apply paired sample t-test. And if data is not normal, normal data and not normal data. For the normal data, we have option of paired sample t-test, and for not normal data, we have Wilcoxon sign rank test. So first of all, we are going to perform the normality test, and the normality test is, you know, that one sample KS test is performed to test the normality. In this case, our hypothesis will be data is normal, and the alternative hypothesis in this case is data is not normal. So let us move to SPSS, where we have already entered the data, and you can see that these are the weights of mice before the treatment, and these are the weights of mice after the treatment. Remember that whenever we apply paired sample, we used to enter data in two different columns. In case of independent, we used to enter the data under observation in one column, and second column usually used to indicate that which group the data belongs to. So let us first perform normality test. I am using SPSS 27, and you must remember that in SPSS 27 the output version is different as compared to 25 or 26. I am using 27, so you must use 27 to get the same output. One sample, and in the fields I will shift my both the variables to the test field here, and the setting I will go for customize test, and then I apply test observed distribution against hypothesized that is Kolmogorov-Smirnov test, and in the options you can specify which distribution you are going to test. So here our purpose is to test the normality. So I have chosen the normal and then I press run. So you will get this output here. So this is table of our interest, first table of our interest, and here I am going to paste that in Word, and here you can see our most important value here is this significant value, because we are going to make the conclusion on the basis of this significance value. So we will say that since the significance value is 0.2, which is greater than our alpha, that is 0.05, so we will accept our null hypothesis, that is data is normal. Now since data is normal, we will go for paired sample t-test. For our main hypothesis. Now let us perform paired sample t-test, and to perform paired sample t-test I will go in analyze, compare means, and here we have paired sample t-test. When I press that, I will shift the variables to the other side, and you will see that pair 1 have weight of mice before the treatment and weight of mice after the treatment. So I press OK. So these are the outputs for paired sample t-test. The first table gives you the summary of the data, that the average weight of the mice before treatment was 199 grams with a variation of 18 grams. And the weight of mice after the treatment has increased to 393 grams with a variation of average variation of 29 grams. Similarly, the next table is of paired sample correlation. There must be significant correlation between the two variables, and it is not significant here. Then we go for paired sample t-test results, and from this table the most important things are this t value, this significance degree of freedom, and this significance value. And another thing is that difference. So if we are taking the sample in such a way that before observations are taken first and after are taken second, then they are taking the difference before minus after. So if the answer is negative, that means there is an increase in the weight. So here we can see the significance value is 0.001, which is greater than, which is less than our specified alpha, indicating the acceptance of alternative hypothesis. So we can conclude that the treatment have affected the weight of mice, and since the differences are negative, that means there is an increase of weight is observed after the treatment. So this was when the normality was there. In case if data is not normal, then we usually don't perform paired sample t-test, rather we performed Wilcoxon sign rank test. So I am going for that as well, just for the purpose of learning. So here we have non-parametric test, and so I was talking about non-parametric matched sample or related sample test. So in the analyze non-parametric related samples, and then from the fields I will choose both the variables and shift them to the other side. So then I go to the setting, and from here I choose the customize test, and here you can see that we have Wilcoxon for matched sample test. I will check that one, and then I press run. So here are the output for the matched non-parametric sample, that is Wilcoxon sign rank test, and that is the significance value of our interest. We will compare this significance value with alpha, and then we will conclude accordingly. Here you can see that the significance value is less than your alpha, so we are going to accept our H1, concluding that the treatment has a certain effect on the significant effect on the weight of mice, and there is an increase is observed. So from here you can see all the differences are positive. That means there is an increase in the weight of mice, and this is the interpretation of this table and this graph. So you have to watch both the videos so that you can learn about the matched sample t-test.